Hi, Nadav. Good to see you again.
Good to see you as well.
You doing well? You okay?
Yeah, I mean, you know, the rest of the world is no Miami, but it's going all right.
Yeah, I had a good time in Miami. It's a beautiful place, like
Yeah.
really awesome. Right, we've got some things to go through. Let me tell you why I want to do this show. I do one of these about once a year because whenever I have friends or family or people reach out to me and they're like, I want to know about Bitcoin, P, and then they ask me about other cryptocurrencies, and I try to steer them away, and then they trying to convince me um, about why I'm wrong. And I always think I'm never good enough to technically explain it. I can explain, rationally why I think Bitcoin wins, why that's the most important cryptocurrency for the world, but I can't on a technical level. And I hear the arguments again and again, but I just feel like I want a show to put in front of them. And I've heard you in some very eloquent debates on Clubhouse talking to other shitcoiners about some of the issues they have. So you felt like the man to get on and talk about this. So how do you feel about this?
Well, it's not what I normally consider my field of expertise, but I'll do my best.
Well, you nailed it on Clubhouse for me. So I think it's definitely in your armory. Okay, so like I've got a methodology of how I want to approach this. So one of the things that I first explained to people about, I mean, I did it this morning, explain how Bitcoin works. I start to talk about the blockchain. Um, so can you start off by just explaining to me the problem that a blockchain solves?
A blockchain is a relatively new mechanism that we have for distributed and decentralized coordination between like a lot of people. So picture like everyone in the world can come together, use a blockchain, and they will all come to the same conclusions about what the state of the blockchain is. So it's a consensus mechanism, is usually what it's called. And for example, that can be used to have this public ledger of who has what in terms of who has what Bitcoins. So if I wanted to send you a Bitcoin, I would publish a transaction to this ledger. And then over enough time, everyone would agree that I had sent that Bitcoin to you. Um, but a blockchain as a technology has some like fundamental trade-offs. So the thing that it solves is this big public coordination that is hard to censor and isn't controlled by any small group of people. But the trade-off is primarily, I mean, there are a couple others, that it's somewhat slow. So, to get everyone in the world to agree that I sent you this Bitcoin should take like 10 to 30 minutes to an hour, depending on who you ask, for how much kind of uh, how sure you want to be that this is final, so to speak. Um, so it's not instant. We have kind of this time after which we achieve finality. It's kind of a rough consensus. But that is kind of the problem that a blockchain solves.
Can we talk about how it works? Because I've talked to you before about how my listener base tends to be a range of people, but I do try and make it approachable for the absolute beginners, and there's always new people coming on board. So I'm going to do some pretty basic questions. You talked about consensus. So what is that?
Yeah, so that's essentially everyone agreeing on what the current state of things is. So, in theory, that doesn't just mean like who has what Bitcoin. It can also, you can put some minimal amount of like data on a blockchain and everyone will agree on the state of that as well. But generally speaking, because things are slow and also the amount that you can put on a blockchain is somewhat limited. In Bitcoin, at least, we try to kind of keep it very minimal and kind of just what the state of Bitcoin is, so to speak. But by consensus, I just mean that everyone in the world like has the same picture of what Bitcoin is owned by who.
So the consensus is like a set of hard rules that the blockchain has to maintain.
Yeah, the consensus rules are essentially a set of rules that if you follow, you'll come to the same conclusions as anyone else who follows those rules as well, given enough time.
But if you break one of the rules,
Well, if other people try to break the rules, they will not succeed. So that's where all of the crypto part of cryptocurrency comes in, and everyone else will kind of rule against them. And if you're breaking the rules for yourself, no one else is going to believe you, and you're just going to have a bad view of how things are.
well, we can probably give a picture of this if we just roughly talk about, well, I say roughly, you, if you explain how a block is created and added to the blockchain, then
Sure.
that would probably explain where the rules come into play.
Yeah. So essentially, what happens, say, if I want to send you a Bitcoin, is I'll construct a transaction that points to some Bitcoin I already have on a previous block, on the blockchain, and proves that I own it using cryptography, using digital signatures. So I sign it, and then now this transaction, which says with my signature that I am spending these coins that already exist on a previous block, and I'm sending them to you. I take that transaction and I like tell everyone about it, and then they tell everyone else about it, and it's kind of this big gossip network where everyone gossips about my transaction until everyone knows about it. Then at some point, a block gets created by a miner who is doing a lot of work, and essentially a block is just a list of these transactions. So it has my transaction that sends a Bitcoin to you. It has a bunch of other people in the world's transactions in it. And it's just this big list of transactions. And it also has a reference to the previous block, hence it's a blockchain, because each one references the previous one. And there are a couple other rules that need to be followed to kind of ensure that this consensus happens. But once a valid block is created, which is essentially just means that a miner has expended enough power, or, all the miners in the world essentially have expended enough power, and tried to just guess a bunch of random numbers until they found one that made the rules valid. Then that block is considered valid, and they gossip about it to everyone else, who gossips about it to everyone else. And then everyone eventually knows about this block. And now, so at this point, uh, this transaction is like known about and considered to have like one confirmation. But in theory, someone else could create another block, like a competing one, that say didn't have this transaction in it yet, that went off of the same previous block. And then we would have to wait a bit longer and to see which of these two potential next blocks gets built on top of itself. So then, everyone who's building blocks chooses one of them and builds their next block on top of that. And then eventually, over enough time, once you have a couple blocks built on top of you, it's essentially impossible to change previous blocks because it requires all of the work not only to create a new block, but also to replace all of the old ones, which would require you essentially, in simple terms, to have like 51% or more than half of all of the world's mining power going towards Bitcoin, which is something infeasible.
So one of the ways I explain this to people is to think about it like a skyscraper, and every block is like a new floor.
Mm,
And what I always say to people is like the transactions that you've created exist within a floor, but we kind of want to wait till like 5 or 6 new floors are built on top, because the reality of going and taking all these floors down and rebuilding them is very unlikely. But if you only have one floor, if your transactions in the top floor, it's kind of a little bit easier to dismantle that floor. Do you think that's a fair analogy?
yeah, that's a good analogy. And then, once you have like 10 floors or 100 floors even built on top of you, it's like that's never going to be changed. That's like very final.
And
Yeah.
it's a different method of payment people have to get used to. If I was to pay you with my credit card or bank transfer, or with any form of like traditional payment, say PayPal, I always know kind of like once I've sent the payment, I'm just kind of like rest assured that it's done. But
Mm.
with this, you have to get through this idea of confirmations. And it's quite
Yeah.
tricky for people to understand. But as long as you've got 6 confirmations, which is 6 new blocks built on top, we think you're pretty safe.
Yeah, that's like super safe. And also, it's probably important to note that when you're using things like PayPal or your credit card, like the user experience tells you the transaction has completed successfully, but it actually hasn't, and it does take quite a while. And they just have built big, intricate systems to kind of manage the risk involved and deal with a certain amount of fraud. And in Bitcoin, like at this base layer that we're talking about, there is no such fraud. Like everything is actually, when we say that it's like final, like it's actually final and irreversible. And there's no way to like back charge your credit chart or your credit card transaction or your PayPal transaction.
Well, that's
Um,
another interesting thing to talk about, which I also explain to people is I talk to them about when you've got money in the bank, it really is a system of IOUs. The only way you can ever actually have that money is if you withdraw it and you have cash. That is essentially final settlement by you taking that cash. But
mm,
until you have that cash, everything's an IOU. And you can't be guaranteed the bank will make the transfers, and you can't be guaranteed that you'll always be able to access that money. Certainly, if you wanted to withdraw a large amount. And one of the things I say to people is with Bitcoin, once that's been sent to you, that is final settlement. You take possession of that Bitcoin and nobody can take it from you.
that's right. Yeah, and we imagine that there will be systems built on top of Bitcoin's kind of settlement layer where you'll have a similar kind of experience to using a PayPal or a credit card, where there's just a different layer built on top that eventually reaches final settlement, but in the meantime gives you something else that you can, for most people will be good enough. But with Bitcoin itself, that's right. It's like it's actually like where it ends. The story ends when the confirmations are reached.
Okay, so you mentioned that because of the nature of this, to be able to have a global system that every single person can essentially have a copy of the blockchain and all reach consensus and agreement, one of the trade offs is that it has to be slow. So if I make a payment, if I buy something from a website in America, despite what you said, I have the belief once I've made the payment's done and it's confirmed, right? But for Bitcoin, we have to say, you have to wait for that 6 confirmations. It can take up to an hour. That's essentially Bitcoin's biggest trade-off compared to traditional payment rails in that getting your head around that time. And we will talk about Lightning later. But can you cover why it is slow and why that is necessary as part of the architecture of the blockchain?
Yeah. So essentially, there are kind of two pieces to this. The first piece is that the blockchain has to remain relatively small if everyone is going to be having a copy of it. So if you imagine like anyone can throw anything in there at any time in the entire world, we're talking about like everyone having a copy, not literally, but like similar in scale to like a local copy of like Google Drive on their computer. Like, no, by Google Drive I mean like Google Drive servers that store everyone's data. So that isn't going to be feasible for everyone to be able to run a fully validating node in that case. Not everyone is going to be able to run all of the consensus rules and make sure that this is a big distributed system without rulers. So, and one of the limitations here is that you have to keep things relatively small. The goal in Bitcoin is that anyone should be able to run uh, a full node, so to speak, on their own like personal computer. That is currently how the state of things are. And if we were to say increase like block size or something so that there can just be more in there, which would reduce the time somewhat, that would actually make things kind of worse in a lot of ways. Like it would kind of it would go counter to the problem blockchains are trying to solve, which is this big distributed, decentralized system of consensus where there aren't a smaller set of people who are in control of that system. So that's kind of one of the more fundamental reasons why things are slow, is because at the end of the day, blocks like block space has to be scarce because, you know, at, like the amount of space on a personal computer is somewhat scarce compared to uh, what could be kind of demanded. Um, and so if block space is scarce, that kind of means that we're going to have some slowdowns with how long it could take to get your transaction confirmed. The other piece is just with proof of work, how we are actually making things irreversible, building those floors. Is not an instantaneous process. It actually requires like energy in the real world to be expended. It's not just like a number changing in a database. It's actually like a bunch of power being run through miners, and those miners are then doing a bunch of work in order to create valid blocks, which also takes time.
So this is probably where it's a good place to discuss the trade-offs. One of the first other cryptocurrencies that people often ask me about is Ethereum. And they don't necessarily talk to me about Ethereum and preferring it because it's faster or cheaper. And certainly at some points this year, it's just not been cheaper. But they tend to talk about it being more flexible. You can do more with it. Smart contracts are really important. I want to get into some of that. But can we also talk about the trade off that Ethereum has made with regards to their blockchain and why that is very different to Bitcoin?
Yeah, so I think those are actually very similar or linked questions. So we have essentially, one of the differentiating things about Ethereum compared to Bitcoin is that you can, the kind of things you do in transactions, the language of things you have to do in transactions is a lot more expressive. So you can do a lot more in a transaction, you can put a lot more data, you can do computations, you can do all sorts of operations on data, and you can do a lot more than just like financial activity, uh, kind of natively inside of a transaction that goes into an Ethereum block. And on top of that, it's like you have a lot more happening. So it's not as slow as Bitcoin, which, as I mentioned, has kind of the corollary that you have far fewer people able to run these fully validating nodes, uh, checking all of the rules to come to that same consensus without trusting anybody else. So the kind of normal flow of things, if you go and you're trying to start, doing things with Ethereum, is you go download some kind of Ethereum wallet that, in the Bitcoin world, we would call it a light client, in the sense that you are essentially to some degree trusting someone else to give you the correct view of the Ethereum blockchain. So you're not actually doing the validation yourself. And if you did want to do the validation yourself, um, it is quite tricky, especially in comparison to Bitcoin, to get the entire Ethereum blockchain downloaded and validating all of those rules. And some people on their hardware are never even able to catch up to the current state, so they're never able to use it. And that kind of incentivizes a lot of people to run their nodes on more centralized services like Amazon Web Services or something like this.
Well, let's talk
Um,
about that. Let's dig into that because
yeah.
I run a Bitcoin node here. I've downloaded Bitcoin Core. Took less than 2 days, and I had the entire blockchain. And
Mhm.
my node constantly keeps up to date. It's always downloading new blocks, and I'm always keeping up with the blockchain. And I did it all on a uh, what are these square Macs called? I don't even know what it's called. What's the little square Mac unit? Mac Mini. I did it all on a Mac Mini, and it's all running and it's perfectly fine. If I wanted to do the same, because what is the Bitcoin blockchain is what about getting closer to 400 gigabyte now?
That's about right. Yeah.
But if I wanted to do the same with Ethereum, do you know how much data I'd have to? We're talking terabytes, aren't we?
Yeah, we're talking terabytes. I don't know the exact number right now. And there's also kind of these distinctions between like, are you in an archival node or are you just a fully validating node or all these things? I mean, in Bitcoin, everyone runs the equivalent of an archival node, so to speak. Like you ran all the data and validated it. Um, or at least that's the default for what you run. And so yeah, we're talking like a lot more, and also there's a lot more computation that has to happen on that data as you are validating it. Whereas in Bitcoin, it's mostly just checking digital signatures, and not running other kinds of computation. And so yeah, I wouldn't expect you to be able to do it on your Mac Mini.
Well, I tracked Eric Wall once on Twitter trying to create a Ethereum full node, and he was struggling. But you did talk about data centers, so are we to assume the majority, if not most, if not all, full archival Ethereum nodes are running out of data centers?
Certainly the majority.
Do we know how
I
many
don't.
there are?
So I saw. I mean, it's kind of hard to get good numbers on these things because it is, at the end of the day, like you could run a node and not tell anyone about it, kind of
Of
thing.
course.
But the estimates I've seen out there are that there's something on the order of like on the order of 1,000, uh, or maybe it was, yeah, I think that's about right. Like fully validating Ethereum nodes, and I would assume a very large percentage of those are running on some kind of cloud computing service. It is very hard for people to actually, especially everyday people. Like I talk to people who are like software engineers at small startups or companies that have trouble, getting an up to date Ethereum node running, let alone like someone on their personal computer trying to do this thing.
But that's not essentially a death knell for Ethereum.
Sure.
If we're trying to be balanced and objective and fair, it just means there's different trade-offs.
Certainly,
So
yeah, and so that kind of brings us to like what do you get for kind of the centralization that's inherent, and what you get is that you can do a lot more, say, natively on the actual blockchain. Um, but I guess at the end of the day, the reason I don't think that this trade off is worth it is because you can do most of those things off chain, so to speak. Like the only thing you need a blockchain for is the thing for which blockchains are good at, which is this kind of final, distributed, uncensorable settlement. And most of the time, because it's so easy to do so much on Ethereum, right? They have a language modeled after like JavaScript, which is one of the most widely used programming languages out there. It's very easy to just like write a bunch of smart contracts and put them on the blockchain, and then it works. But it's also super expensive to use because everyone's trying to do all of this stuff on the blockchain itself. Even if you make block space a little less scarce, it still is scarce. And if everyone is trying to kind of use the blockchain so heavily at the same time, it just doesn't scale very well. And we can see all of these kinds of scaling troubles of trying to do everything on chain already on Ethereum, and Ethereum certainly does not have like worldwide adoption in the way that someone might hope that such a system would do in the future. And so kind of even in Ethereum, they understand at this point that how you scale these things is with layer twos and going off chain and doing things off chain. And I think the more you look into kind of how you scale these systems, the more you see that like at the end of the day, you don't really need a very, very completely expressive base layer. And that's not actually a trade-off really worth making.
and another thing that I find concerning about Ethereum is that if we looked at Bitcoin, my biggest worry, concern for myself ever is a mistake I make that leads me to do something stupid with my Bitcoin or to get hacked. And so, I've set myself up a multi-sig solution, distributed my keys, and I feel pretty safe and comfortable with that. The only times I tend to hear about people losing their Bitcoin is from their own personal mistakes and trade off for decisions they've made in holding their Bitcoin or trusting someone else. So they've got hacked by a scammer, they've given away their private keys, or they've messed their security up. But something I've noticed with Ethereum is that people can lose money because of a bad smart contract or a hacked smart contract, things that get locked up. And they could have the best security in the world. They could have, they could really, put a lot of decent practices in, but there are things that are out of their hands which can lead to them losing some of their, Ethereum or tokens.
Yeah. So, yeah, there's lots of kinds of, because it's so, everyone writes very extensive smart contracts, and at the end of the day, those contracts, that code, its execution determines who has what. And if someone has a bug in their code, as always happens, when you're working with large code bases at scale, then you end up with people losing money, or funds being allocated to places that the users aren't expecting. And so a great website to kind of scroll through that I found recently is called rect.news. And it kind of describes all of the quote unquote hacks, though they're not really, like, Ethereum is not being hacked. Ethereum is just, there are contracts on there that have been poorly written that can be exploited by people, which is normally reported as a hack. So it's not that someone's breaking cryptography or something like this and stealing funds from users. Like, if you viewed the Ethereum blockchain from a super purist position of like code is law, as they used to say, then like this is just normal operation, is a bunch of people unexpectedly losing their funds because that's what was in the code, because there were bugs in the code, or at least unexpected features in the code.
That rec.news is interesting. I just had a quick look, and there's like 16 events in May alone. It's nearly pretty much every 2 days there's been an event.
Yeah,
which
and
is
each of these things, like, it's just like millions and millions and millions of dollars worth of coins being stolen left and right all the time. So that's that's certainly another trade-off of having an expressive base language, especially an expressive base language such as like Solidity, which is not as far as like programming language theory goes, like the most secure thing to write super money sensitive code in. Like, I would not use a language like JavaScript to handle my money, just as a programmer. But yeah, I guess so. There's kind of that added kind of design decision in Bitcoin. Not only is it restrictive to keep things small, right? We could have other ways of keeping things small. It's also super restrictive because we don't want there to be any foot guns, which is what we call like these. You could picture like a shoe that has a gun pointing at your foot, and it's like, why would you design such a shoe? Like, someone's obviously going to at some point pull that trigger and shoot themselves in the foot. So we try to avoid all foot guns and make it super minimal so that you really have to kind of work hard to mess up, so to speak.
So I got asked a question today on Twitter of what a maxi is, and I tried to think about whether I am or not, because like sometimes I know I act like one, I can be a bit toxic, bit dismissive of other cryptocurrencies. But to be honest, I did reply honestly. I said, look, my work is Bitcoin, and that's what I focus on, but I can see a time where I would potentially use Monero because I'm not particularly competent technically, and trying to create a private transaction on Bitcoin and trace what I've done, that would be very difficult to me. I would probably mess it up. But I know with Monero, I feel a little bit more comfortable creating such a transaction. So I can see scenarios where I would use Monero. I don't hold it, but I can see with that. And I also said the thing about Ethereum is I don't like it. I don't understand it. There's a lot of things that I'm not particularly a fan of, but at the same time, large parts of the Bitcoin ecosystem benefit from stable coins. There are people who use stable coins to trade in and out of Bitcoin, and that stable coins do benefit people around the world who want to hold a digital asset, but they don't want to hold Bitcoin because of volatility. So I kind of question myself, saying, well, am I being a hypocrite because I support the idea of stable coins, but I don't like Ethereum? You can put Tron in that bracket as well. So I kind of don't care if people want to use Ethereum. It's their choice. I'm not happy with the trade-offs, and I don't really use stable coins anyway. But one of the things I wanted to ask you about is that there appears to be some concerns with Ethereum long term. One, the bloated blockchain, and secondary, the move to something which we call proof of stake, which is a different consensus mechanism from proof of work, which is Bitcoin. I know I've put a lot out there in this last kind of, I don't want to call it a rant, but this last kind of point I've been making. Like, I guess what I'm asking you is, I'm not asking you to validate whether Ethereum is useful or not just because stablecoins are, but what is the long-term risks that Ethereum faces because of their trade-offs, and how much concern is there around the move to proof of stake?
Yeah. So I guess first off, you're totally right that like, bloated blockchain is a big problem, especially seeing as earlier I forgot to contextualize the numbers, like the 400-ish almost gigabytes of the Bitcoin blockchain. That's like over a decade's worth of blockchain, right? And with Ethereum, we're actually talking much less time and much, much, much more data. And so as time goes on, Ethereum is being used a lot more right now than like its first couple blocks when it was first created. So we should expect it to grow even more, even faster, to some extent. And so certainly that is going to be an issue. Like if it's already an issue right now, you shouldn't expect there to be a very large distributed network of fully validating nodes. And you run into all the issues that kind of come with centralization when trying to the problem blockchains are supposed to solve is that they're supposed to give you this big distributed decentralized network, which isn't necessarily a good in itself, but it does mean that a government can't come in and censor your transaction easily, or all sorts of other kind of games that can be played with more centralized systems. Kind of control does not exist in some small group of people's hands. And that isn't necessarily the case if you keep on making it harder and harder for people to actually check the rules.
Actually, I've got just a question on that, because one of the things I'm aware of with Bitcoin is that it is censorship resistant. If I want to send Bitcoin to you, it will get to you. I think the closest we've got to censorship of the Bitcoin blockchain is OFAC sanctioned addresses, which aren't actually censoring the blocks themselves and censoring the addresses. They're just scaring people into sending transactions to them. But specifically on Ethereum, one of the things I'm aware of is with some of the stable coins, if you look in the terms and conditions, they actually say they can blacklist addresses. So why is it possible for them to actually blacklist addresses in Ethereum when you can't do that on Bitcoin?
Yeah, so actually, one dirty secret of the smart contracting world is that many, I guess I don't know exactly how to qualify this, but there are plenty of smart contracts out there which kind of have upgrade mechanisms, meaning that if a bug is found, they're going to want to swap off to some other fixed contract. But one way of doing this is just a certain number of people need to sign off. Essentially, it's some version of having admin keys for the smart contract. And so you can imagine there being some mechanism by which some relatively small group of people can decide that some addresses just aren't allowed to use this contract, which would essentially, censor that activity. So aside from Ethereum as a whole, which is kind of what we've been talking about, individual projects and contracts on Ethereum themselves can very easily be fully centralized entities, which kind of begs the question, why would they be using Ethereum for this? This is you're making this trade-off where you're getting slower, bloatier, harder to use database, and you're getting nothing in return because you're just centralized at the end of the day. You're not using this decentralization very much. So I do think that there is kind of a lot of marketing that happens that is maybe another piece of the trade-off. That's what they actually get from this. And it's not actually necessarily always technological innovation that is happening behind a lot of projects.
Yeah, so if you have those centralized keys, you might as well just build this on a traditional database, which would probably be cheaper, faster, more efficient.
Yeah. And you can even have a distributed database, but just with between the people who would have admin keys, or something like this. You don't need everyone in the world to be validating your database if it's just a private project.
Yeah.
And,
Okay.
yeah.
Sorry, go on.
Or no, I was just gonna say, not exactly private, but like pseudo private, or just some small federation that controls it.
So let's talk about proof of stake then, and we should probably talk about what proof of work is that Bitcoin uses,
Yeah.
and why that's important, and why that is what we believe as Bitcoin is the fairest way to run the consensus.
Yeah. So essentially, how proof of work works is miners have to, or a valid block, let's start there, is one which, follows all of the like template rules. It's a list of transactions, it references a previous block, it has been written down correctly, so to speak. But then there's this one extra rule, which is that the hash of the block has to satisfy a certain constraint. Now, a hash, you can think of it as just this like magic cryptographic function that takes in some data as input and spits out a random number. That's how we model hash functions. So you can think of this as just like a pseudo random number associated with a piece of data, and a block is only valid if its hash is like very small as a number. And so there's one spot on the block that is just a number, and it doesn't have any rules associated with it. It's called the nonce, which is like a one-time use number. And all that you do with the nonce is, if you're a miner and you're building one of these blocks, you write down all the transactions and you reference the previous block and you do all the things you need to do. And then you start just guessing numbers to put in for this nonce. And then you run this hash function, which spits out a seemingly random number. And then if the number isn't small enough, which it usually isn't, then you try a different number and guess again, and you'll get a completely different random number. And you just keep doing this over and over and over again. And this is what is taking up the energy. You're computing a bunch of these hash functions. Computing a single hash function takes like milliseconds or less. It's like very, very fast. But because of how small the outcome needs to be compared to what it could be, and there's a uniform distribution. It's as equal that you get any number, and there are way more big numbers than like very, very, very small numbers. And so this is kind of the work that it takes. Is miners have to do this over and over and over and over again everywhere in the world, and on average, over the entire world, you get one block that's correct every 10 minutes. And we actually adjust how small the hash needs to be to keep that property, that we get about one block every 10 minutes. No matter how much energy is being thrown at the Bitcoin network, we should be getting about one block every 10 minutes. But what's really nice is once you have one of these valid blocks, someone found a nonce that works, then validating that the nonce works takes like a millisecond, right? You just like hash the data once, as opposed to like some penta something. I don't know. Like there's some crazy number of hashes that are actually computed before you find the correct block. And then the reason that this gives you nice security and immutability, as we call it, which just means things don't change. So irreversibility, kind of like we were talking about with the skyscraper analogy, is that once you've built that block, that took like the entire world some very large amount of energy, expenditure, and work, essentially, to compute. And now say you've got a couple more blocks built on top of it. Now the consensus rules, like the rules you follow if you want to get to the same conclusion as everyone else, is you follow the chain that has the most work done on it. So, in simple terms, you can generally think of this as follow the longest blockchain. So if someone else wants to reverse this transaction and like not include it in the blockchain, they would have to go back, like say 6 blocks or something, build a different block off of or go to the first block where right before your transaction was included, and then they'd have to build off of that their own block. They'd have to expend about as much energy as the entire world did in order to find a correct nonce that gives you a valid block. And then they'd have to do that again, like 6 times. And by the time they're able to do that, they have to do it many more times, probably because, more blocks have been added during this. So essentially, if you model this in simple terms, the only way that this works is if you have more energy yourself than the rest of the world combined. If you are able to do more hashes than the rest of the world combined, eventually you'll catch up. Otherwise, you probably won't. And so that is kind of where the security of Bitcoin comes from. So the energy expended, kind of like if you could put a number on that, which many people have put many approximate numbers on that, that kind of is equal or proportional to the security of the Bitcoin network. Proof of stake, which is something that Ethereum will be going to, but currently Ethereum still uses proof of work. There are lots of other blockchains, though, that already use proof of stake, is a separate system that kind of avoids work entirely, and essentially just tries to play this, I'll call it loosely a game, in order to decide which blocks are valid and the ordering of things and kind of all of these consensus issues. And generally how it works, kind of has, as the name describes, is if you hold the coin for this blockchain, you can stake that coin to kind of be entered into this lottery of some kind, in which, or lottery or vote, depending on, there are lots of, proof of stake itself is not one thing like proof of work is. It's actually somewhat broad, and there's delegated proof of stake and this other kind of proof of stake, and each blockchain has its own variation. And one of the many documentation sites that I've found fail to actually talk about it in terms of an adversarial model. When you find documentation about proof of work, you'll hear about 51% attacks, because that's how you model the security. It's what would it take to attack this system? Whereas most documentation out there does not talk about how you attack proof of stake, so it's kind of a less well understood security model, if you will.
But you must have thought about it.
I've spent some time, but actually what I found is that one of the best places to find critique of proof of stake that's actually looking at it critically in an adversarial model is look at a different proof of stakes project that discusses why they took those trade-offs. So if you can find some other blockchains documentation about why they followed different rules than Ethereum, and they'll critique the Ethereum proof of stake rules, and then you'll go somewhere else and they'll critique their rules. So that's kind of a fun tidbit. But essentially, at the end of the day, what you're doing is you have kind of this game played between stakeholders, so people who actually hold the token, where by some mechanism, one person is chosen to create the next block and put it out there. And if they don't follow the rules, then there is some other game played where, in theory, what should happen is that their stake should be either burnt or given to someone else, or in some way they should be punished for cheating. But kind of the problem here is that at the end of the day, if you actually do look at it adversarially, you're looking at this pseudo government structure where you have maybe some checks and balances, but usually it's a pretty straightforward thing, but where everyone is anonymous and you literally buy your votes. Votes are literally just money. So it's kind of you take all the worst things about government and amplify them and get rid of a lot of the checks and balances and judicial system and all the rest of it. And it's just some small group of people who aren't elected, but rather buy their votes, get to decide what happens. If you view it kind of from a cynical model where you're what would it take to actually attack this system, as opposed to what most documentation shows, which is what's the happy path? How does it work when no one's attacking the system? Which is a very different story. But then an additional problem, with this is that you are then rewarded for your activity in staking, and so you kind of have this self-perpetuating system where In Bitcoin, you have to actually like expend real world resources in order to get this block reward. And, generally speaking, most miners, activity, the amounts that they make is like, they work at pretty thin margins. Whereas in a proof of stake model, it really is like, in some
100%
sense,
margin.
yeah, you assuming that you don't get your stake destroyed or something like this, you just the people who have more money get more money, so to speak, which is familiar.
Yeah, well, you say familiar because it feels a little bit like the system we're already living in. People often talk about the Cantillon effect with regards to the fiat money system, and it feels like proof of stake is a repeat of this.
Yeah, it certainly has some undesirable properties. And then the other thing is that I don't think it's actually, it tries, especially with its name and how it's presented, to kind of borrow the the brand power of like proof of work. But in reality, it is like a very different system. It's I like to think of it more as a trust model than as like this big distributed consensus model. Like you could think of Bitcoin mining as a trust model, but there are just so many parties involved, and the barrier to entry is low enough. Like in terms of if you have a competitive advantage, you'll be a fine miner. And it's also something that kind of you have to like in Bitcoin upkeep. You can't like pass it down to your children, right? Whereas like you could imagine someone who has a lot of stake passing it down to their children who then don't necessarily have any like even if you're thinking about like it starts out as the people who actually care about the system are the people holding the stake, but like no one's to say their children will care about this system and won't just abuse all of the power that they get from that. um so that's kind of another consideration, but proof of stake very much is kind of closer to trusting a much more not really governmental game as opposed to Bitcoin, which is more just this like very simple, uh, well understood, very distributed game. But I guess I do personally view proof of stake much closer to just a trust model that, in theory, you could model on like a Bitcoin blockchain if you're willing to trust that like 200 of 399 people. So the majority of these 399 people are going to act correctly. Then you might as well just use like a very, very large multi-sig on Bitcoin and use them there instead of having this entire separate system that has all these games that they can play and be rewarded for cheating.
Yeah. See, one of the things about Ethereum that I've struggled to see in the same way as maybe some Bitcoin maxis is when they refer to Ethereum as a scam, because in some ways, Ethereum is better than what we have as a current centralized banking and financial infrastructure. There's certainly some things which are better than it. It's it's less centralized. There's certain things about it which are I mean, I would say, whilst it may not be trustless, it's still fairly permissionless.
Yeah, and I think it also like I've been talking a lot about how, in theory you can do all of these kinds of things in layer 2s in Bitcoin. This is all like very cutting edge, research that, people are building these things out today. Things like Lightning already exist, but the next version of Lightning is going to, have even kind of more stuff you can do, and as we move forward, kind of it's more that we know how to do these things, but that doesn't mean that if you want to like make a startup and you want to do something uh, with Bitcoin, it could be significantly harder to do today than if you used something like Ethereum or some other blockchain. Um, and I guess I tend personally just because I'm more on the research side of things, to think on the super long scope where I can see like where things on Bitcoin are going, and I'm not worried about there being some kind of lack of functionality. But I totally understand that like today it's like a lot more work because we haven't yet built out all of this to do things on Bitcoin as opposed to someone else or somewhere else. I actually like to use a skyscraper analogy for this as well, a different one, where I think of like, Bitcoin, we're trying to construct the super long term, for the entire world to use system. And we're starting, we want to build the skyscraper. So we've got to go down like super deep into the ground to build this foundation. And it's going to take a very, very long time, just like we're still kind of starting to come out of that underground section and start to build some floors on top. But in the meantime, other people have built little 4-story buildings that like you can already live in and you can like go be in there. But there's no way that you can then like take that thing, that foundation, and like build a skyscraper on top of it and have it be safe. Like that's not how it's going to happen. So from like a long-term view, which I think is probably like the view to take if you're thinking about uh, long-term things, I guess, if you're looking to put your wealth into something or use something for your country or something like this. You want to take that thing with the super like deep foundation, even though like maybe it can't do everything today. It can do some like bare minimum financial transactions and some other interesting things on it today. That like in the future we're going to have this giant skyscraper, and if you had settled for the 4-story building, you're just stuck with that and it's not going to scale. Like the entire city can't live in a 4-story building. You need a much larger building for that.
Well, that's quite interesting because Ethereum 2 is in the works, and it looks like Bitcoin's nailed it in its kind of first iteration. There isn't a requirement for a massive re-architecture. Now, look, I know you'll say there are versions and there are versions,
And
upgrades that we
Taproot and
have, and
upgrades, yeah.
but they are upgrades. But Ethereum 2 is essentially a re-architecture of the
That's
system.
right. Yeah,
and
all of Bitcoin's upgrades to date have been backwards compatible. So
yeah, and what I tend to think about is going back to what I was saying previously with Ethereum. In many ways, Ethereum is better from the centralized banking system we have now. But I just see it as, in terms of money, purely in terms of money and a way of storing wealth, I see it as significantly inferior to Bitcoin. But there's also certain things about Bitcoin which I think is still inferior to using pounds and dollars, mainly volatility, acceptance, etc., etc. Like Bitcoin hasn't solved everything just yet. As a long-term saving account, which is hedging against the debasement of the currency, I think it's great. So I just don't see a use for Ethereum for me. But I've struggled to call it a scam because some people have found use cases. It's not for me. I've got no interest in it. And I think calling it a scam, actually, it kind of it, if you call everything a scam, it kind of loses meaning for what a real scam is, like a OneCoin or any kind of like like full on scam that's existed. I tend to say there are scams, there's silly ideas, and then there's Bitcoin. So that tends to be my thing. And I know that's gonna, like, some maxis gonna be like, "You're a fucking idiot," blah blah blah. But it's just that's the way I logically think through it. Because if it's solving a problem for somebody, if they want to use it, then fine. Somebody can transfer wealth through Ethereum and they can spend it. I might not like it, but it is serving a purpose. But nothing you've said has made me want to own Ethereum or use it. We could talk about lots of other different blockchains. We could talk about Polkadot and yada yada, Chainlink, but I think generally you'll be repeating yourself. And there's a couple of other things I do want to talk to you about instead. So one of the things that Bitcoin solves is a mass distributed network, but traditionally it's not been great for small, fast transactions. Yet we do now have what is called the Lightning Network. I was using that in El Salvador. I was buying cups of coffee. This is really the Bitcoin expanding to that point where it can be a transactional system because it has this transactional layer. So do you want to explain how, you don't have to go into too much detail, but what the Lightning Network is and what this adds to Bitcoin?
Sure. So the Lightning Network, one way of thinking about it, there are many, is the problem that the blockchain solves is that it lets you reach this kind of global distributed consensus without any like centralized rule between peers that don't necessarily have to trust one another, right? It's kind of, we have this nice don't trust, verify kind of ethos where you don't have to trust the person who you're paying to act correctly or the person who's paying you. You can just verify all of that. But kind of one of the key insights behind the Lightning Network is you don't need to use the full power of the blockchain, right? This like super mega consensus building machine to buy a cup of coffee, right? It's kind of like you wouldn't go to the grocery store in a tank and be like, sell me groceries. Like, no, they want to sell you groceries. Like most financial activity that people experience day to day is like consensual and good for both parties and like something that people like don't need like violence or blockchains to enforce. And so what the Lightning Network lets you do is it lets you avoid using the blockchain unless there's actually a dispute of some kind. So it essentially uses the blockchain as a settlement layer and only as a settlement layer. And then all of your other kind of transaction activity is just happening without going on the blockchain. And it's only peer-to-peer. It's not the entire world that needs to know about it. And it's very fast because you don't have to go on a blockchain. And but it's still kind of fully enforced by the blockchain in the sense that if ever there is a dispute between people, they can just actually go on the blockchain and have the rules of the blockchain kind of settle their dispute. So it's in some sense, it's this trustless cooperation mechanism. So it's trustless because you're still backed with the Bitcoin blockchain, but it is a cooperation mechanism which allows you to avoid actually using the blockchain and having all of those downsides. By just it's a very specific cooperation mechanism that uses a bunch of interesting cryptography and other things like this to kind of allow you to take these off-chain transactions, just like, very quick, less than 2 second, scan a QR code, hit send, it's done kind of user experience, where in like 99.9% of, all of the cases that you'll see in the world, like that's the end of the story. And then only in cases where like someone is misbehaving do you actually have to use the power of the blockchain to punish them. And this is kind of like the way I've described it this way because this kind of describes a lot of layer 2 very broadly. It's not just the Lightning Network, like other things built on top of Bitcoin will have these properties that you don't want to use the blockchain unless there's actually some kind of dispute. All cooperative transactions in the world can exist off of a blockchain, and there's no reason to actually use a blockchain for them. And Lightning is kind of the first iteration of this. It's primarily focused just on transactions, not on fancy contracts, which is kind of the stuff I'm working on, which will be going on Lightning in the future. But these days, you can use Lightning to send Bitcoin around without actually having to use the Bitcoin blockchain directly.
So we can buy coffee.
You can buy coffee.
All right.
Killer app.
Killer app. I want to know a little bit more about what you're working on in a moment. Just the last thing I wanted to touch on before we get onto that is I do want to talk a little bit about Monero. Have you spent time looking at that enough for me to ask a couple of questions?
Depends on the
questions. Well, look, I've always struggled to dislike Monero. I think it has this kind of like interesting origin story. Like Bitcoin, we don't really know who created it. And I have used it in the past. And the reality is, as I said earlier in the call, if there's certain transactions I would want to do, back when I first first used Bitcoin properly was to get cannabis oil for my mum for treatment. So if I wanted to do that now, I would be nervous using Bitcoin because I now know that I'm probably KYC'd on all my coins and can be tracked. And if I do mix them, then maybe there's certain places I won't accept. There's a lot I don't understand. And I'm very nervous that I would still be tracked, even if I thought I did everything right. I feel a little bit more confident using Monero. So, despite what others think, I could see a use case where I want to use it. Also, whenever I talk about Monero, all the Monero shills or Monero fans, whatever you want to call them, they all jump down my neck and go, well, Bitcoin isn't fungible, Monero is fungible, yada, yada. So firstly, I want to ask, can you just explain what fungibility is, why Bitcoin doesn't have it and why Monero does? And then my second question is, are there any kind of critical flaws with Monero that I'm not aware of?
Fungibility is the idea that you can kind of, if I have like, one Bitcoin here and one Bitcoin here, like if I swapped those and now I had that other Bitcoin instead of this one, then I would be in the same place that I started. So you can think of like cash as fungible, right? If I have like a dollar bill in my hand and you have a dollar bill in your hand and we like swap, like neither of our lives have really changed, so to speak. So the claim that Bitcoin is not fungible comes from this idea that different transaction outputs, which, as we discussed earlier, like really what it means to have Bitcoin is that someone has sent it to you previously and you have not yet spent it. So that's an unspent transaction output. So that's the fast version of what's a UTXO. But essentially, the idea is that if you then had a different UTXO, like the thing about Bitcoin is you can go audit the entire history of each coin and they would have like two different histories. And, the worry is like, what if someone does like blacklist an address and then like that gets sent somewhere else, and like somewhere in the history of this coin, there's a blacklisted address, and somewhere in the history of this coin, there isn't, or something like this. And so the claim that Bitcoin isn't fungible kind of comes from this notion that Bitcoin is not particularly private about like coin history and things like this. I think most people would, I don't know that most people would agree with that, even today. But I think most people would agree that like we are moving towards that not being an issue in Bitcoin at the very least, if it isn't already an issue. Things like Taproot really improve, which Taproot is the recently locked in upgrade for Bitcoin. Really improve things like fungibility, where the notion that you can like create like bad coins by like blacklisting addresses is becoming less and less actually enforceable and practical. It's kind of a dubious claim. You can execute things with Schnorr signatures like with the new Bitcoin upgrade, like coin swaps, where you can untraceably swap coins from one place to another. And also there are things like coin joins and using Lightning and other things like this, which are off chain, essentially to make it impossible to actually enforce a ban on a person like in the real world. So I think that it's a much more nuanced conversation in any direction, whether you're talking about Monero or Bitcoin, and it's kind of disingenuous to just go with the one-liner. There's a little bit more to it, but certainly I think you will find that among Bitcoiners, like if any other coin had an even slightly soft spot within them, Monero would probably be that coin that they're like, okay, whatever, Monero can exist, if they're like a Bitcoin maximalist or something like this. And I think the key things to kind of consider are the following. So I think, right, the use case, so to speak, especially today, like this is another thing where I think in the future, Bitcoin, the ability to use Bitcoin privately will be much easier than it is today. There will be tools that just work out of the box for if you want to specifically use Bitcoin privately. There are trade-offs, and some people might not want to use those tools, but people who do want to won't have to be software engineers with like a PhD in how to analyze privacy on a blockchain to know if they're doing it correctly. I'm exaggerating a little bit, but not by too much. But yes, so essentially, I think in the future, maybe I'll reevaluate. But in the meantime, like as I said, if you want to do certain kinds of things on Bitcoin today, like maybe if there's use cases for other things. The first thing to note is like that doesn't mean you should necessarily go put like all of your savings in this thing, because right, like if it's being used only because people want to use it for private transactions, like that doesn't bode well as a store of value necessarily, but maybe it's fine as a medium of exchange for like in and out kind of scenarios. At least to some extent. So that's one thing to keep in mind. Another thing to keep in mind is that its goal is privacy. Like a key difference between Monero and Bitcoin is Bitcoin wants to be this like world currency that works for everyone and that you can store your value in. And because of that, we've made some design decisions, such as the one I mentioned previously, that all Bitcoin upgrades are backwards compatible, right? Like we're not going to go like pull the rug under and be like, you have to update, otherwise you don't have money kind of system. And in some sense, people talk about like, we're not allowed to like go and like invalidate Satoshi's coins. That would be bad. Like those will still have to be spendable in the future. And Monero, on the other hand, and a lot of kind of blockchains that are out there that kind of don't have the same goals as Bitcoin, uh, they take this other trade-off where we call it hard forking, but essentially it's just a non-backwards compatible upgrade to the network. So it's an upgrade where everyone has to change. So one of the kind of tenets in Monero is that everyone has to use the same feature set. So when they upgrade their privacy feature set, everyone has to use the new one. They can't partition like some users using version A, some users using version B, because that's bad for privacy. And so then that's kind of the one of the bigger trade-offs I would say to consider is that you have to upgrade all the time, and it's not the kind of thing that you can easily just like put something in it and then like walk away for a couple decades and then like come back to it. That might not be super trivial. And so that's one thing to consider. Whereas, Bitcoin takes kind of this opposite approach. And then the second thing to consider, maybe on a longer time scale, which again, maybe this is not actually an issue today, but in the future, the hope is that there will be potentially many more people using the kind of privacy tools that are easily available to people on Bitcoin than the total number of people using a project like Monero. And I'm not saying that's just like, I'm saying this could happen. I'm not saying that this will
No, it makes
happen,
sense.
but right, the goal of forcing everybody to update is so that you have as big of an anonymity set as possible. But in Bitcoin, we have a couple different, we keep all of our old versions and all these things like this. But if we actually get this giant mass adoption that Bitcoin is built for, you might actually have a larger anonymity set over here on Bitcoin than you would using kind of this other tech. But I personally haven't made up my mind on whether or not that is how it will play out. Maybe Monero will always be around for certain kinds of use cases. I don't picture it being a store of wealth, but I don't think
Exactly.
anyone would be like, that's not what it's built for anyway. So it's not a problem.
Well, I mean, I'm there with Bitcoin as my store of wealth. There's nothing that's come along that remotely challenges my thesis, and I imagine, for quite a long time, perhaps even the rest of my life, be using Bitcoin as a store of wealth, because I'd be surprised if something comes along which is a superior technology for that.
That
But
would be a nice surprise.
that would be that. Yeah, it's the it's a lot about what Dan Held talks about, where it's the immaculate conception of Bitcoin, which is something that's really hard to beat. And so, I'm pretty much there with Bitcoin. With something like Monero, like I say, I would still use it as a medium of exchange for certain things if I felt like I had a private transaction to do. The thing is, I don't, and I don't. That doesn't really come up for me. And some people say, "Well, you should care about every transaction being private." And I'm like, I understand, but just the trade off of buying the coins, sending them, selling if I need. It's just a bit too much for me. I just can't be bothered. That's why, even now, sometimes I still use PayPal because it's just easier than using Bitcoin. Sometimes I still use my bank. Like I've accepted these trade-offs, but I know certain scenarios where I may use Monero. I also know there'll be certain scenarios where someone may request Monero from me, and I'm okay with that. I'm absolutely fine with that. But it's good to know that those trade-offs. Awesome. Well, listen, I think we've covered enough on this stuff. I've got more on my list, but this, I think, covers the main things I wanted people to get an understanding of. But I would love to hear about what you're working on, especially with smart contracts on Lightning. I probably won't understand anything you're talking about, but it sounds interesting.
Sure. Yeah, so the big kind of project I'm working on has a big scary name, which is Discrete Log Contracts. We'll call them DLCs because none of those words are too important for anything I'm talking about. But essentially, they are a way of having what are called oracle contracts on Bitcoin, where an oracle is just you can think of it as an entity which attests to something that happens in the real world and like brings it into the digital world. So they're a trusted entity, at least somewhat trusted, not necessarily like I trust you with all of my wealth, but more like I trust that two of these three oracles will tell the truth. And if they don't, like, I guess I lose the small amount of money I put in this bet with my friend or something like this. But essentially, what DLCs let you do is they let you enter into fully kind of peer to peer, no third party involved in actual kind of setup or execution contracts, which how who gets what Bitcoin just depends on something that happens in the real world. So you can imagine, there were plenty of people we were testing things out with in Miami who were making small bets on the Logan Paul Mayweather fight. And we had some oracles that were attesting to that event. And, people can pick an oracle, find someone who wants to take the other side of the bet with them, set up one of these discrete log contracts or DLCs with that person. And then when the thing happens in the real world, that executes the actual contract on Bitcoin. And the nice property, or like kind of the goals for DLCs are, we want to use the blockchain as little as possible, right? So all the contract logic, all that stuff, that's all off-chain fun cryptography stuff I do. And the only thing you see on-chain is like Bitcoin moving from one place to another. So it's only for the kind of transfer of value that we're using it for. And because of that, we're going to move these things onto Lightning in the future, because Lightning also lets you do this transfer of value. But kind of at a high level, you can picture using DLCs for things like prediction markets, things like kind of some financial derivatives markets. A lot of people these days, talk about DeFi. This is kind of like Bitcoin DeFi in some sense. I know that some people really don't like it when I call it that, but I'm calling it that anyway. But essentially, it's just in my mind, like the reason I'm interested in DLCs is because I just think of it as like one of those foundational building blocks in this skyscraper for like most interesting contracts that move Bitcoin around are going to have to do with things in the real world. So we're going to want some way of bringing those in. So it's kind of just this building block of allowing real world events to affect where Bitcoin goes on the Bitcoin blockchain. And none of this requires new blockchains. It's just like some fancy, cleverly constructed cryptography mixed with some other hard work that goes into it. And hopefully someday that goes on to Lightning along with lots of other things that you can do with Bitcoin off-chain that just uses Bitcoin as a settlement layer.
Right. So are they good to go? Can you play with them? Are they in development? Are they in testing?
I would say that they're in they're in alpha testing right now. So it's I wouldn't recommend non-technical people to go play with them, but if you are technical, then they are out there and you can play with them. And we're working. It's actually not just like Suredbits, the company that I work at. It's not just us. It's this big open source project. We've got developers all over the world who contribute to this open source project. We're kind of trying to follow in Lightning's footsteps for building out specification and multiple implementations and all of this kind of thing. It's something that is out there, and we're hoping to have a more stable version of it out there kind of sometime, hopefully this year. I don't know if I should make that promise, but it's relatively soon that we will have this out there packaged in an app that you can actually go play with, even if you're not a technical user. And there are also people already building things on top of DLCs. So the best example that comes to mind is there's a company called Atomic Finance, and they have an app that I think is currently in like a beta. So it's on like test flight on iOS that some people are already playing around with. And it's just like an app on your phone that lets you do covered call options. So kind of these relatively low risk yield things that you can do, or yield strategies, if you will. that you can just on your phone do some things, and then what's happening in the background is it like builds a bunch of DLCs for you. So our goal is to actually like have this be a building block that people who are building apps on top of this, like with Lightning, you don't need to know all of this complex stuff about how we use cryptography to settle things on chain and stuff like that. Like that's my work, and everyone else can just build on top of that, and not just my work, but also this big open source community.
Well, it sounds amazing. And listen, I appreciate you coming on the show and explaining all this stuff and dumbing it down and making it easy for people to
I
understand.
hope
Because
brought
killed
it
it.
low enough. I have a tendency to say words like discrete and log and contract.
Well, I have a tendency to not really understand a lot. So if I don't get it, I just make you explain it easier. No, you did a great job. I think it's going to be really useful to people. So appreciate you coming on and doing this. Look, if people want to follow you or follow your work, where can they do that?
Yeah, so I believe I'm Nadav_Kohen with a K on Twitter, I think. Let me double check that. But as I go, I'm on Clubhouse, as you know, a fair bit, explaining things to people there, and I got my Twitter handle correct. I'm N Cohen most other places, NKOHEN on. I guess I don't know why I'd be showing my GitHub here, but there also.
There may be some people listening.
Yeah,
Who want to look at your
I
GitHub.
have written quite a bit in the Suredbits blog about a lot of these things. I try to have some higher level posts and some more technical posts. So if you want like summaries of what discrete log contracts are, or how Lightning works, we have like a Lightning 101 series, or how various other things in Bitcoin work, Taproot, the upgrade, or all sorts of stuff. We have a semi-technical, but some of the posts in there are just summaries and stuff. Blog at suredbits.com/blog. That's suredbits.com/blog. I have written a lot.
Right,
so if you want to follow my work, I usually write about it.
All right. Well, listen, I will share that all out in the show notes. I appreciate you coming on again. That's twice now, and I won't be afraid to come and ask you again. Really appreciate it. And next time I'm in Miami, which I think is going to be early October, for the Human Rights Foundation's Freedom Forum. Let's hang out, man. Let's catch up.
Yeah, if I'm there, I'll hit you up.
All right, nice one. Well, listen, take care, Nadav. Thanks for coming on, and speak to you soon.
Thanks for having me.